Take a can of soda and a can of diet soda and drop them each in a big container of water. What happens? Why? Discuss. Here's a photo in case you don't have soda to experiment with. There are 39 grams, nearly 8 teaspoons of sugar dissolved in the water of the regular soda. It takes a much smaller mass of aspartame, NutraSweet or equal, to flavor the diet soda. When you dissolve powder into water, it does not change the volume of the liquid, but it does increase the mass of the liquid. How does that affect the density of the liquid? Discuss. Since density equals mass divided by volume, that means that density and mass are directly proportional. If mass increases while volume stays the same, density also increases. To make the can of Coke float, you need to increase the density of the water. If the water becomes more dense than the soda will float. Add 13 ounces of salt, half a standard cylindrical cardboard container, to about 3 liters of water. The sunken regular soda can will rise to the top of the water, and the floating can of diet soda will rise high enough to tip over and float on its side. Make a Cartesian diver. As you squeeze the bottle, what happens? Why? How does it work? Discuss. Here are a few ways you can make a diver. In case you can't make one, watch the below video. Now that we've learned how to calculate for density, you will use your skills to find the density of various objects and then determine whether each would sink or float in water. We learned earlier that, with one exception, solids, liquids, and gases all expand as they get warmer, and that they all contract or get smaller when they get cooler. Their mass is constant with temperature. So, what does that mean about their density as they heat up or cool down? Discuss. The density of a substance changes with temperature. As temperature decreases, the same amount of mass shrinks down to a smaller volume, creating higher density. As temperature increases, the same amount of mass gets larger in volume, creating lower density.